maybe we've spoiled you with calculators, but I have many people who miss how to divide fractions. Just plain old ordinary numbers like over there on the right. How do you do Yes, you reciprocal of which one? The bottom one. Reciprocal of the denominator. Yes. Uh-oh. Uh-oh. All right. So, yes, one more time we were going to, you all said I should multiply by the reciprocal of the denominator. And then it's just a multiplication problem like every other problem we just did. So, what can I cancel? 3 goes into 9. 3 times 2 goes into 4. Or 2, I said that back, yeah. We get 3/2. Okay, so if you see a problem like this with the variables and it's got a division sign, I would just, as soon as I'm copying it out of the book, what should you immediately do to it? Yeah, just flip it over and multiply it right as you're writing it down. There's just no reason. Because you know when you divide, it means multiply by the reciprocal. So you're really just going to rewrite that second one flipped over. The first one's going to stay as is. Second one's going to become multiplication. Okay, then back to the same thing we just did. Since these terms have pluses and minuses in them, you get to factor them. All right. What's weird about the first numerator?
Wait, about what?
What's weird about the first numerators? It's backwards. When the variable's in the back, that should be a warning signal. And all the others have the y's, the highest y power up front. That screams at you, reverse me. How do you reverse it? Take a negative out, make it become 4y squared minus 9. You're gonna do that like every single day of this chapter. You have to reverse things. Okay, now tell me what will factor.
Oh, you know.
4y squared minus 9. You should look at those and go, oh, they're all squared things.
The 9s will both take in 2y plus 3.
Yeah. 2y plus 3 and 2y minus 3.
Where do you see that at, huh?
Because that's perfect squares. You'll have 2y and 2y, 3 and 3. You're going to get really good at these factoring rules. This is going to make you good. Okay, the bottom one's 3 terms. What's the only way we factor 3 terms ever? Unfoil it, yeah. So break it back down. So it's got to be a y and a y. To make 9, it's got to be
3.
And since all my signs are positive, you're right. It's got to be plus and plus. So that's just normal trinomial. Okay. This next one is also a trinomial. So what should I try?
Oh, yeah.
Same thing. Factoring it. But this time's a little trickier because it's a 2y squared. Yeah, that'd be 2y and 1y. Okay. Now, this one's actually kind of sneaky because we know it's got to be 3 and 1.
Minus 1 on this side. No. Plus 1 and then minus 3.
Plus 1 and minus 3.
I hear several plus 1s and then minus 3.
Yeah, that's right.
So check it.
No. Plus 3 and minus 1.
Because your outers are negative 6 and your inners are positive 1.
Plus 3 and minus 1.
Negative 6 and positive 1 is going to make a negative 5 in the middle, so that's not going to jive.
Plus 3 and minus 1.
Okay, so do you want me to move the 1 and the 3, or you just want me to switch the pluses and minuses? Yeah. Because I would want this to be a plus 3 and a minus 1. That way I'll get a positive 6 and a negative 1 will make positive 5 in the middle. Okay. Is there anything to do with that bottom one?
Yeah.
Yeah. Yeah, it's got a common factor. You can always look for common factors. You can pull a 4 out of that thing. So you'll have 2y minus 3 left. And then, it's the fun part. You get your pencil. Okay, I heard the... 2y minus 3's got it. Okay.
2y plus 3.
y plus 3's, yep, I could get those y plus 3's. Is there anything else? And then I can't. Okay, guys, there's no law that says lots of stuff has to cancel. You can be left with a whole bunch of stuff. And a lot of times it happens. In this case, we don't lose anything else. So you're stuck with all of it. Now, the good news is you do not have to FOIL this back together. You just leave your answer in factors. So just write down every factor you've got left. I'm going to put that 4 up front and then take it times the y plus 3 that's left. Now, you should always then eyeball it one more time and go, okay, is there anything that would have canceled that I missed? Nope. So you're left with all of it. But you don't have to multiply it back together. You may leave it just like that.
I'm glad we don't have to multiply back together. I am also.
Alright. So, alright. So you go ahead and got the multiplication and division mastered. Let's add and subtract.
Wait, there's more?
Heck yeah.
For addition, subtraction, common denominator.
Yes. Okay, it's back to the good old days. How do you add 3/4 plus 7/10?
Turn around the ratio.
Okay, and okay, you all look at numbers now, and you just know common denominators. Like when you see 4 and 10, what is the smallest common denominator? 20. You don't have to go, oh, it's 40. Oh, 40 would work. 20 is better. It's smaller. Okay, now, I know this is basic, but what I'm about to do here with numbers is exactly how you do it with variables. Okay, so if I'm going to turn these both into 20s, what do I have to do to the first fraction to make it have 20 in the denominator? I have to times it by 5. So but if I times the denominator by 5, I have to times the numerator by 5, which will give me what? That will give me 15/20. Okay. And so then I go over to the other fraction and I go, oh, I need to multiply it by a 2 to make it be a 20th. So therefore I would then have 14/20. And then the big question, how do you add fractions? You add the numerator. Do you change the denominator? No. That stays 20, and so therefore you have 29/20. Or 1 and 9/20, but we aren't going to mixed fractions. Okay. That process is exactly how you do variables. Just be slow, methodical, and think about it. Okay. So when you look at this thing and you go, what's my common denominator? Okay, this is a quantity. That's x plus 2 is a quantity. It goes together. X minus 1 is a quantity. So if I want you to add that, what's my common denominator going to be? Okay. I would actually, I have to have, since there's an x minus 2 in this fraction, x minus 1 in that fraction, my common denominator has to have both of them in it. That's a plus. So you actually, in this case, if those are totally different, you have to have one of each in your common denominator. And so that means the other one's common denominator is also going to be that same thing. All right, now, what did you have to multiply the first original fraction times to make it have that common denominator? It needed an x minus 1. So you are literally taking this times x minus 1 to make it have the common denominator. Okay. Now, on the top, actually multiply that together. What will you get? Minus 3x. Okay, so let it sit. Don't do anything to it. It's happy. Just let it sit for a minute. Always have people want to start breaking that back down. If you break it back down, you'll just cancel it right back to where you started. It won't do you any good. So don't, just let it sit. It's happy. What does this fraction need to have that common denominator? It's missing the x plus 2, so we're going to take it times x plus 2. Okay, you will never, ever FOIL the denominators together. The denominators stay as separate quantities. You don't want to FOIL that. That's bad. But the top, I need to multiply the numerators together, which in this case means I truly do have to FOIL this thing. So, okay, how good are we at FOILing in our head? Because, can we do outers and inners in our head? Outers are positive 2x, inners are negative 5. So 2x and negative 5x would be a total of negative 3x. So, or if you need to write it out, all I did is I did 2x minus 5x there. I did outers and inners. And then subtract, do the last. The last are going to be minus 10. Okay, once again, don't resist the temptation to factor this. You multiplied it together, just like up here. Did we break 15/20 and 14/20 back down? No, after we got the 15 and the 14, what did we do? We added them. So now you add the numerators. Add up your like terms across the top. Okay, 3x squared and 1x squared would indeed be 4x squared. Minus 6x minus 10. Just add up your like terms across the top. Do you change the denominator? No, it just stays there, happy little clown that it is. Okay, most of the time, you're probably done right there. But occasionally, you do need to look at it. Now that you've added it together, is there any chance it might factor and cancel something? Well, there's a possibility. You have to check and see if it might. If that top would factor and cancel, we would need to reduce it. But what do you first notice about 4, 6, and 10? I could pull a 2 out, couldn't I? That would leave me with 2x squared minus 3x minus 5. Now, will that factor? I'm going to run myself out of room here.
No.
Maybe?
Yeah.
It kind of looks like it might. It'd have to be, it'd have to be 2x and x, wouldn't it? It's got to be a 5 and a 1. Okay, I definitely don't want the 5 back here because I don't want 5 times 2 to make 10. That would be bad. So it's got to be 5 in front, 1 in back. Okay, what about sign?
Minus 5 plus 1.
Minus 5 plus 1. Well, would that make negative 3x in the middle? Outers and inners would, so yeah, I'd say those are good factors. Now, did it help us? Darn it, we came so close. X plus 1, x minus 1. It's so close, but no, it doesn't cancel. Okay. Yeah, actually, in this case, if you have to go that far, I could live with this original one we had up here with the 4x squared, or I can live with that factored down as the final answer either way. So, it could be this is good, or this is good. Either one is okay. But that's what can be kind of frustrating about these. You can get so close, and it looks like it's going to factor and cancel, and you're going to get this great simple answer, and then it crashes and burns.
Why?
So, are we having fun so far?
Yes.
It's okay. It's common sense. What's the biggest problem you're going to have with these? What's going to be the biggest issue with these? Factoring, just not making simple little errors. Getting your factors wrong, messing up a plus or a minus. It's the little stuff that eats us alive on these.